A very good day to our lecturer Dr. Izian and all those watching this video. Today we from Group 10 would like to do our video presentation on our group project. Okay. Let me introduce myself first. My name is EBENEZER NAVIN and my matrix number is 193205. I'll be telling you all about the background of the problem and the methodology of our project. Let me start with the background. A reinforced concrete commercial center of 40 meters long and 18 meters wide, comprising of 6 stories, is required to a city's suburb. Open plan office with no solid walls proposed to have a maximum amount of light entering into it. Reinforced concrete beam and columns are used as the main structure of the building. The design of the building is undergoing analysis of 2D and 3D structures with the aid of the softwares such as LinPro, SAP 2000 and STAAD Pro under various codes of provision. The analysis is performed for certain subframes and level with the respective static load given. Since we are in group 10, so our live load will be for the ground floor and first floor is 5 kN per meter square. In the second floor will be 3 kN per meter square. In the roof, it will be 1.5 kN per meter square. For the dead load, the self-weight and the finishes will be 3.8 kN per meter square. Going into the methodology. The span of the frame are selected from the 3D structure for the use of the 2D analysis. For the manual calculation, moment distributed method is being used. LinPro analysis is performed at the middle span of the structure. For the 3D structure, STAAD Pro and SAP analysis is performed. The data is tabulated and the percentage errors are calculated with the formula, which is percentage error is equal to the absolute value of approximate value minus exact value divided by the exact value times by 100%.
I am CHWEEN and I will continue about the assumption we used in this project. So in this project, we have used 8 assumptions, which including the codes, the beam self-weight, rigid joint, static load, the modulus of elasticity, live load, adverse site condition, and also the manual calculation. So the beam and column self-weight is neglected in the analysis. This is for easiest analysis in the 3D software. Second, the rigid joint. So all the joint is assumed to be rigid, where the axial force and shear force is neglected since it's very small. Third, only static loads is considered, which consists of live load and dead load. Dynamic load such as wind load and earthquake load is not included in our analysis. Fourth, manual calculation is assumed to represent the exact value for the percentage error calculation, whereby this means that all other analysis such as 2D software LinPro, 3D software SAP 2000 and also State Pro will refer back to the manual calculation to compute the percentage error calculation. Fifth, the modulus of elasticity of the concrete is assumed to be 21.718 kN per meter square. This value is used because in State Pro, we cannot alter the modulus of elasticity of the material. Therefore, we choose to use this default as our modulus of elasticity for other software analysis. Sixth, the live load QK for third floor to fifth floor is assumed to be same as the second floor, which is 3 kN per meter square. 7. Site condition is assumed to be adverse, whereby the maximum load will be 1.35 dead load plus 1.5 of live load, where the minimum will be 1.35 of dead load. So these two is used, and then the result is compared, and the biggest value is chosen to be used as our result in comparison. The code used in this project including BSEN 1992-1-1 C1.5.1.3. So this bring the alternate span loaded condition, whereby one span will bear the 1.35 GK plus 1.5 QK, whereby another side will bear the minimum of 1.35 GK only. Another code is the Malaysian UK National Annex. This is in the condition of all span loaded. So these two could use, and the load combination is used between these two, where we do alternate span first and then continue with all span loaded condition, and then the bigger value will be taken as our result for those analysis.
Moving on to the next presenter, I would like to address myself. My name is TAUFIQ bin AZMAN. My matrix number is 197905, and I will be presenting on the percentage area of our building analysis. In this analysis, we use 2D analysis and 3D analysis. In 2D analysis, it is used on manual calculations and LIMPRO software. In 3D analysis, SAP 2000 and StatPro softwares are used. For the percentage area calculation, 2D manual calculations is assumed to represent the exact value of the loaded frame. This is due to prevent any human error when using LIMPRO as the representation of the exact value. Percentage errors are calculated by the formula below, which are percentage error equals to approximate value minus exact value over exact value times 100%. Moving on, this table shows the maximum moments from both 2D and 3D analysis that we have conducted. As you can see here, we divided into 3 levels, which are the roof, the first floor and the second floor. And we measured out all the maximum moments on both 2D and 3D analysis. So this is the percentage area that we have calculated from both 2D and 3D analysis. As you can see here on the 3D side, we notice that the StatPro is a lot more closer to the exact value, which are the manual calculations, than the SAP 2000. This shows that StatPro is more accurate and more precise compared to SAP 2000 software. We deduced that there are differences in the values for 2D and 3D analysis due to the limitations in 2D analysis part. In 2D analysis, for all these members, the 2 dimensions perpendicular to the thickness are considered as much larger than the thickness. It is therefore only the beam size that must be defined as cross-section property by the user prior to the analysis. This is due to in the client's proposal, it is suggested that we use the typical beam size that has proposed by the client, but it is only applicable to 3D modeling. So therefore, that is one of the limitations that 2D analysis have. And also, when using 2D modeling techniques, there are strict rules to be applied to obtain the most accurate results, and which the main rules that follows are the ratio between thickness and area of the beam itself, as the use of a large thickness to area ratio plate will enter the realm of 3D modeling, where all assumptions made using 2D elements no longer holds true. So in general, it is obvious that the 3D modeling is more accurate and more precise to be used in building structure analysis compared to 2D modeling. That is from my part. Moving on to the next presenter.
So hi and Assalamualaikum. My name is AMIRUL bin JASMI. My matrix number is 199143. So for our structure analysis 2, for group project, I managed to handle in software part, which is SAP 2000 for version 16, and also in conclusion part. So let's go. So this is our consideration of the structure. We consider that for the beam section, we use 0.3 and 0.55 0.3 meter times 0.55 meter, which is 0.3 is for the horizontal and the 0.55 is for the vertical, and same goes to column section, but for the vertical we use 0.5 meter, and that's the unit we use kilonewton, M, and also C. The modulus elasticity we use 2 with the power of 2 times 10 with the power of 8. And we also consider that material we use for beam is concrete. For the column we use as rebar. And as stated in question, for our concrete compressive strength FC we use 40,000 kilonewton over meter squared, and minimum yield stress Fy equal to 490,000 kilonewton over m squared. Right. So this is our structure. Okay. As mentioned in question, we need to assign 18 meter times 40 meter of our structure building. So for our number base of x, we use 10, 1, 2, 3 until 10. From here, from here to here is 10. So 4 times 10 is 40. For number base of y, we use only 2. 9 times 2 is 18. So 18 meter times 40 meter. So this is our side view. You can see I already label it. This column, this is beam, this column again. Note that our support is fixed support. This is from side view. Previous is our slab is from plan view. Okay, so this is our uniform distributed load from side view. So for the roof is 29, for the first and ground floor is 50, while for the rest is 38. We can see when we go down the floor, the UDL is increasing. This because the lower floor will try to restrain the upper load. So this for shear force diagram front view. I'm sorry that this is not clear. I just can extract like this from the software. I don't know how to make it more detailed. I can just take this. This is our shear force diagram for front view. This is our shear force diagram for side view. As I mentioned, when we go down the floor, it will increase. You can see 74 until 130. Next is moment. This is side view. We know that moment can be influenced by SFD. So when SFD increase, so the moment also will add the same. This is from side view. Why this is from front view? Also from front view get also problem. We cannot extract it more detail. I can just take it like that. And this is the deflection. As if you alert, you can see the difference of this structure compared to this structure. You look, this more rigid, while this not so rigid, and this is the deflection. This is the original structure, the blue one, and the bright one is the deflection shape. This is from front view. So this from side view, we can show it clearly. Is the deflection, and also deflection, and also we can view this more clearly. This is deflection. Okay, so for the conclusion, we use two types of code, which is BS EN 1992111C M13 and also Malaysian UK National Index. So from this analysis, it is clear that 3D analysis is more accurate and precise. Why I say that? Because as we know, this project requires us to do some analysis of 2D and 3D for the building structure, right? So so we do the analysis using software. So for our group, we use LimPro, SAP, and StatPro, and we analyze it based on different load combination of several subframe. So when we analyze 2D subframe of our roof, first and second floor, and then we calculate and compare it to manual calculation and also compare it also to 3D, what we get is the 3D analysis is more accurate. So next conclusion is usage of software is very important in designing processes. Absolutely, because as I said, when you using software, you will get the measurement is more accurate, and when we use the software, we can save our time. Instead, we use our manual drawing. So for the recommendation, we need to change the material of the beam itself, which has larger modulus of less density and larger dimension. Because of what? Because when we change it will influence reinforcement, and the reinforcement will be increased. So our structure will be more stable and strong. So the recommendation also, we have to construct the beams with fiber reinforced concrete. It is because we to enhance the durability and overall toughness due to its higher structural and shear strength. That's all from me. Thank you.